Sum is just what it sounds like, except this one is a little harder because instead of just taking numbers in, it also accepts strings, which of course can get very large, and big ints, which can get arbitrarily large. So how are we going to handle it? Have you seen, so Trash, have you seen anything like this before?
I mean, at a high level, yes. Probably not covering nowhere near as many test cases as this one. But anytime I hear math, like again, like my intuition is always accumulators and stuff. But
yes,
I'm sure there's some cool optimizations we're going to be doing in this one. So I'm curious to see what happens.
So this one is not passable because of, I think just because of this test, number 16 with accumulators, because you'll hit the recursion limit very quickly. So that's what makes this one in the extreme set. Okay, so let me show you one of the solutions. So if we jump down to line 176, so we already have something interesting. A extends number like. Number like is just string or number or big int. So, okay, fine. We're going to use that a lot, so it's no big deal. But that's what it is, just the things that we accept for this function. And then we're doing a join. And the join is going to create, it's not going to create a single tuple for like that is the length of the number like you might expect, and then like kind of add those arrays together. There are tuples involved here, but it's a little more clever. So
okay,
let's get into it, but like we'll kind of do it in reverse, I suppose. So toString is just going to convert the number to a string, and then we're going to split that up into its digits, right? So it shows us, if you hover over it, it shows you like split foo, and it returns FOO, 3 members of an array.
Yep.
So then now that we have the digits, then we can operate on like each register, and we're going to have to implement carrying in order to add, because if you add 9 plus 9, you have to carry the 1. So that's what sum of tuple does. And then at a high level, sum of tuple is going to, you can probably guess now, is going to return it shows you if you hover over it or if you go look at the JS doc, if you add 23 and 9, we're going to get back 32.
That's insane.
And then join is just going to turn that 32 back into a string. Where's join?
Right.
So join is pretty straightforward. It's just like if it's an empty, okay, so it's if an empty array or empty tuple, we return nothing. And then we're just going to like recursively add those things back together from right to left, actually, because that's how number systems are. If you're doing them like by the lowest digit. So sum of tuple is where the magic happens. So let's take a look at that. So broad, like high level view, does everything except sum of tuple make sense? Like what the approach that we're taking is?
Yes, for sure.
Awesome.
It reminds me of like HotScript. Now that I've been looking at HotScript lately, it just like every time I see it, just looks, I don't know. It's like all I see.
So what like I can keep kind of narrating it. Oh, we got something off the screen here. I can keep sort of narrating it, but tell me, I'd like to hear your thought. Like, what do you think about sum of tuple? Like as you look at it.
It's a lot to digest on the spot for sure. Like for me, my immediate thought, like if I was going to just approach this by myself, like my mind is already kind of exploding on the carrying.
Okay.
So like I feel like the most complicated part for me, at least, is probably the carrying, but maybe it's simpler than I think. But
yeah, let's talk about it. Okay. No, it's all good. So that's actually really good to know, like what is interesting about it. So okay, so this is the carrying kind of flag, if you want to think of it. It can be a 0 or a 1. So it starts off as 0, meaning there's nothing to carry. But if it's a 1, that's what this block handles. Then we're gonna need to do all that. So let's take a look. Let's just start from the very top. We'll take it slow. Let's look at tuples are empty. So basically, tuples are empty is only going to return true if both things are empty. There's actually a trick that we can do this in. I hope I'm not going to make a mess here. But A, B extends this. Sometimes people are excited by learning about this kind of approach, so I thought I might show you. It still passes. So you can double up those checks like that. Have you ever seen anything like that?
Can you undo it and do it again?
Yeah. Actually, I'll do you one better. I'll copy it, and then we can fit it on one line. What's the big difference? I try really hard. I don't think I've mentioned to you yet. I try super hard to keep these viewable on a phone. because I just want it to be nice and big. So that's why I do this. Okay. So backing up. There.
Okay, that makes sense.
Right. Not so bad, is it?
Oh, that's much. Yeah, I like that. I'll have better.
It can be doubled up. So if you have a bunch of conditions, it kind of works like an and. If you have a bunch of conditions that you want to check in order, you can check them like that. But anyway,
I like that.
That's an aside. That was like it was like a little dessert to keep us.
It's berries. You only have one ternary versus some nested stuff.
Definitely. So all right, tuples are empty. So if they're both empty, then what we want to do is check whether because the reason they would both be empty is because we're going to be recursing. So like eventually there's going to be nothing left to add. So if there's nothing left to add, then all we need to check at that point is whether or not we had a remainder left over. So then we're gonna add that remainder is basically how that works. Otherwise we just return what we got. And again, we're returning a array of digits. And so like that's how that would work. Okay. Then we have the recursion. So pop. Let's go up to pop. Pop is on line 110. Okay. So we have these helpful things here. So pop 234 is just gonna return 23. So we're checking first to see. I mean, we have to do this check to see if it returns. I think it will we won't get a failure. Okay. We don't have to do the check to make sure that this empty tuple. That's probably because of the situation it's used in. It's already been validated that they're not empty. That's tuples are empty is doing that work. So A and B are not empty at that point. So that's why we don't need it. Okay. But so coming back to it, we're going to just grab off the first value and return it. So very straightforward. Sometimes you see people do this there's different ways of doing this, but that's pretty much it. Okay. So we pop off the values and then we do a sum of 10. 10 of sum, rather, is what they're calling it. But anyway, with the last thing, with the last value. So we're kind of separating out everything to the left and then grabbing the digit that we want on the far right. When we get that digit, we also need to care about this 10 guy because maybe we have already carried. So if we go to 10 of sum, there's a helpful little thing here. So t plus a plus b. It's asking, is t plus a plus b greater than 9? If it is, then we're going to return a 1. If it's not, we're going to return a 0. So this is like asking the question, do we need a new digit now because we have to carry? The way that actually gets computed is with a lookup map. So this one, I have two solutions here, one that uses a lookup table like this and one that doesn't. I don't know if we're going to have so much time to go through the second one, but basically, these, like, let's look at one example of that. So 10 of sum of two digits. So A and B. So A and B can be strings. Let's say they could represent, let's say like 2 and 9. So if we go up and look, it's an array of arrays, right? So if we go to 2, 0, 1, 2, we're going to get to this one. And then if we go to the ninth thing, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we're going to see 2 plus 9 does need to carry. So we have a 1. So instead of writing, like, the reason this is important is that you would have to build up more structures in order to actually do the check. You could do this check with TypeScript, but by hard coding a list of like what to do in a given pairwise combination of single digits, it's just an optimization. We can avoid doing much work. Doing a simple lookup in a constant like this is super duper easy. And TypeScript has lots of caching inside the compiler, and it can do this work really pretty straightforwardly. So yeah, any case, that's that. Let's keep going. Where were we? 10 of sum. Okay. So if we have to, this is saying, like, again, this is asking, do we need that carry digit? So that's doing the lookup. If we don't need the carry digit, we're going to do this sum mod 10. Let's go look up at that. So what is the sum of these two values mod 10? That's all this is, right? So the sum of 7 and 4 is 11, and 11 mod 10 is 1. So that's getting the remainder left over from maybe the carry, but probably not the carry. Like there might be a carry, there might not. At this point, it doesn't matter because we've already handled that carry digit. Now we're doing that modulo operation with the single digits using this little lookup table as well. Are you with me so far?
Yeah, I'm with you.
Awesome.
I just would never have thought of just to make a lookup table. I've tried to make it really hard for myself somehow.
It's really not possible. I guess the second one that I'll show you does do a little bit of that, but I think these kinds of optimizations become really critical as you get into big int size numbers, because if you take an approach like this, actually TypeScript is not doing any real addition. We're just doing we're handling pairwise combinations of digits, and then what's 100 digits? It's 100 recursions. It's not that much.
Right.
So actually you can get super duper large numbers doing approaches this way. And it's pretty straightforward.
Do you know how many you can do with this solution? Until it breaks?
Let's try it. Yeah, let's start adding here. Sup 1. So 1, 2, 3, 4, 5. We'll use that. 1, 2, 3, 4, 5. I don't know. That's got to be sufficiently large, right? It looks, did I send the wrong thing through? Let's grab this. Oh, I did. I pasted too many times. It's probably gonna churn for a little while and then come back to us. We'll come back to it. But yeah, pretty large, I think. Okay, so sum of digits. Where were we? Okay, we were down here on 170, I think. Okay. And then, now that we have those values, we can handle them. So this is doing the same thing. This is looking up. This is one big long lookup. So there's the first chunk, and here highlighted is the second chunk. So again, it's just those pairwise combinations. Maybe it makes more sense now why we're putting the sum mod 10 in the far right position, because we want to handle, we have already gotten whether or not we have that ones place to carry or not. So it just works out that way, and we don't need to do more. So we can just grab it. And this is the accumulator. This last argument here is the kind of result. So we're just appending the values up to this point, and then the rest will be handled when we recurse. So it's going to recurse on line 165. So we don't need to do more work than that. We just need to handle computing the digits that we're at now, and everything else will happen in a following step with a recursion. And again, we're only recursing the number of digits that we have. That's how many recursions we'll have from a high level perspective. There's other things going on, but that's the high level view of it. That's it. What do you think?
It's nuts. Every time there's any math involved with TypeScript, it's just
it's bonkers.
I feel the difficulty exponentially shoots up, which is great. It's fascinating. I love it.
I made a video, somewhat esoteric, kind of fun video with Daniel and Ryan Cavanaugh from the Daniel R from the TypeScript team, and it was all about the kind of esoteric, high level design goals of TypeScript is kind of what we talked about. And I mentioned that to them, that anytime that math is involved, you have to resort to these really boutique tricks. And basically what they told me was but we don't really want to give you more tools to do that because you can do that stuff now. And it's maybe not necessarily good for everybody if there's even more stuff to do math in the type system until they're very pragmatic about it. They're until there's until somebody can show why a library really needs to do this.
Yeah, I agree with that. It's for me, whenever I see these, are more for just academia and fun type things. And that I've yet to really, at least I haven't ran into a use case where I was I need math in TypeScript right now.
So
but it's amazing.
So this one is a little different, but it's not that different. Again, this is, I should say the names, sorry, JSuder-xx on GitHub. And the last one was from, I try to credit people, UUID. I think UUID was the creator of this challenge, if I'm not mistaken. Let's see. I should have mentioned that. The creator of the challenge that's whose solution we were looking over first.
I'm curious, when you go through these solutions, do you look for specific people? Because I don't think they're ordered by popularity or anything, right?
I didn't.
It's kind of just PR date.
I didn't for the first 100, but after 100 of these, there's actually only around 10 or so people who have solved every challenge.
That makes sense.
So I get to know them and I comment to them and tell them this is amazing, thank you so much, and stuff like that. I'm a bit of a fanboy. So yeah, this person JSuder hasn't done so many, but Yingsang Meta, Team Chong, Just Bad Programmer, Human Detail, UUID. There's a couple names I could spout off real quick that like I try to look at every solution. I'm a bit of an extremist. I try to look at literally every solution when I'm preparing so that if there's anything really, really weird and interesting, because there are things that I have caught that are so interesting and so, oh man, we're going to get off the rails, but I have one that you're going to love. There are sometimes really obscure solutions that somebody just like tried a weird thing and it happened to work that are so beautiful and so wonderful. For example, this one is one of my favorites of all of the challenges. This one for integer, here's what integer does. It returns the number basically if it is an integer. So if you have a float there, it won't work. But if you have like one, it's giving me an error because we already have A2 defined above, like whatever. But the point is, the way this one works is so clever because it abuses how TypeScript stores things internally. And so it's checking a number, but it's coercing it to a string. But it's seeing if what's inside of that string is coercible to something that matches a big int. Do you get it?
Yeah, I get 100%. Like, why couldn't it?
The other solutions for this have,
I guess, why couldn't you do just, wouldn't t_extends number be suffice?
No, because 1.1 is a number.
Oh, okay. I didn't even think about that.
Yeah, this is checking integer. Most of the solutions, like here's another one, for example, down here. Like most of the solutions look like this, or there's like they're like checking with the dot in there and looking for the dot, or some other kind of trick, or like
that sounds like something I would have done for sure.
Yeah, absolutely. And actually, if you look at the top 100 results for this solution, that's all of what you'll find. Here's another one, but I try really hard to look through because like. I didn't think of this when I started this journey with all of these challenges, but what I realized pretty quickly is actually sometimes what's most interesting is not solving them, is not looking at a solution. It's looking at the differences between approaches of different solutions. So I try really, really hard to prepare. Some of them, there's one that I prepared for 4 hours with that Matt Pocock and I did together in the extreme set. That was just like, there were only 10 solutions, but they were all like completely out there, took a lot of effort. But anywho, this one is a little easier on the eyes for because it names things a little different. There's like, instead of having these little tuples that have like pre-canned meanings, we're building up objects that give us a result and like a Boolean saying carry or not. So if you look on like line 77, we're saying like, oh, okay, do we carry or not? It's there as a Boolean, and then we can like check that. So if we go to add one digit, we can see what's going on with every particular value. So I can look at like carry is a Boolean. We're going to just create this little guy here. And then we don't have to create this generic. You could actually infer right out of the object. But the point is like, it's really a straightforward way of handling stuff. And that's why I like this solution. It just shows that like you can still, like if you need to resort to making maps of structures, you don't have to create tuples where you're like indexing on things, because some of the, like there's a line from the one we were just on that was like pretty kind of rough to read, where you have multiple indexes nested. Here, I'll put it on line, I don't know, line 62, where we had a line that looked like this.
Yeah, this line is super
and it's
rough.
Like, yeah, that's really takes a lot to think through. But if you have something where it's like, oh, carry true, carry false, you have the digit representing the result, and then, you know, all that other stuff, they still did do the work, right? We're saying like, we're going kind of piecewise. This is like add 1 to digit. So we can still do the work, subtract 1 from digit. So they didn't have to implement add and subtract in order to do this, which is another nice thing of this solution. So, you know, you can try to check those things and get some values out, and then, you know, do the work that way. So it's pretty cool, but it's not like remarkably different from how you would go about it with that approach. It's super duper long. Of course, we're not going to go through the whole thing. If someone wants to go again, you can look on GitHub, and this is posted on GitHub, the solutions that we come up with. But yeah, what do you think about it?
So this one in the beginning, it reads a lot easier, right? With the objects that you can see.
Yes.
It looks like it the trade-off is it's a lot more nested ternaries from what I can tell.
Yes, and it's a lot longer in general.
Yeah, because you just kept scrolling. I was like, oh, okay.
Yeah.
But initially, it makes more sense for me because, again, with tuples, it's like this assumed, like the mapping of indexes is kind of in your brain. Like you have to keep track of that. But with objects, it's like a lot more obvious, a lot more explicit. So I do like that. But at a glance, it's like when we got to the nested ternaries, it's like, oof, okay. So I would have to like put them side by side, but I like either solution for sure.
Yeah. It's just, that's what's cool about it. It's the spice of life. Like, I think there's different situations where it calls for different things. And, I'm actually not a big fan of using like T and U and V, like single letter names for things and stuff. And sometimes when you have complicated things, it's a signal to like, let it be, like create more helper types, let it be longer, and then when the day comes that you have to maintain this shit, like you can come back and actually understand it a little easier because there's like some help.
I think my brain is backwards because I almost understand non-descriptive generics better than I do with descriptive ones.
Stop it.
It's weird. Like someone will give me a problem, like a solution with name generics, and I actually go in and refactor it to TUV just because for some reason it messes with my brain. Because sometimes like in instances like this, it's really hard to name generics, but I guess that's like to your point. It's like that's why you do helpers to kind of help give like some actual meaning to them. So
exactly, yeah, definitely, cool. All right, well that's how you add. That's how you add super big numbers in TypeScript. I guess it never did. This one never did come back to life. We probably crashed the TS server.
Yeah, it's probably dead. It's probably
it's
literally dead.
Comatose. Okay, on to the next one.